Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to talk about Descartes' rule of signs. So first, a pointless introduction about René Descartes, because you deserve to know who he is. Probably the greatest mathematician to ever come out of France. He was also a philosopher. You may have heard of him come up with the famous phrase, "I think, therefore I am." He is also credited with the invention of the Cartesian coordinate system, which is the basis of all analytical geometry. And of course, he is known for making Descartes' rule of signs. So let's say I have some function, p of x is equal to 3x squared plus 11x minus 4. And let's say I wanted to come up with the solutions of this function. The first thing I would do is I would set it equal to 0 and try and factor. And if this doesn't factor, I would use quadratic formula. But Descartes wasn't interested in that. He was just interested in how many solutions there would be here. And basically what he discovered is that the number of sign changes as you go through the terms, like for instance, 3x squared plus 11x stays positive, so 0 sign changes, but then you go from positive 11 to negative 4, and that's 1 sign change. And so the number of sign changes you have is equal to the maximum number of positive real solutions. So in other words, in this example I just made up, there is 1 sign change, and so that means there is going to be exactly 1 real solution to this function. Excuse me, 1 real positive solution. And then it gets even more interesting, because he discovered that if I find p of negative x, which to find p of negative x, I'll just tell you the shortcut. Whenever you have an x to an odd power, like 11x here, it switches the sign, so it's like minus 11x now. And then everything else with an even power of x stays the same, so still positive 3x squared. The constant will never change because that's like x to the 0 power, and 0 is an even number, but you can just remember the constant stays the same. And anything to an odd power, x to the first, x cubed, x to the fifth, that's going to change from positive to negative, or vice versa. Anyways, with p of negative x, again we count the sign changes. There's 1 from positive to negative 11, and then it stays negative for negative 4. So again, there's 1 sign change, which means that there is going to be exactly 1 real negative solution. And since we have 1 real positive solution and 1 real negative solution, that is a total of 2 solutions. And the reason why that's important is because anything with x squared can only have a maximum of 2 solutions because of the x squared. That means at most 2 solutions. So these 2 solutions are real, and that means we have room for 0 imaginary solutions with the number I. None of that. And so now I need to tell you about sign charts, because this is the most likely question you're going to see on the test. Make a sign chart for the function. And on the sign chart, you can have positive real solutions, negative real solutions, and imaginary solutions. And so for the example that we just did, we have 1 positive real, 1 negative real, and 0 imaginary. And that's it for this sign chart. Kind of a boring example. What gets really interesting is when your sign chart has a number with 2 or higher. Let me explain. Let's say for the sake of argument, I choose a function that had 2 sign changes for the original and 2 sign changes when I switched it to p of negative x, and still 0 imaginary. So whenever I have a number that's 2 or higher, this is where I can have multiple answers. Let me show you how. I have to deal with these one at a time, so first I'll deal with positive real. I just have to say that I can also have 0 real. In other words, I just subtracted 2 and y2, because it has to do with the fact that imaginary solutions are always complementary to each other. So if you have 1, it's like conjoined twins, you're always going to have a second imaginary solution. But just take my word for it, always just subtract 2. And I have to account for both scenarios where I have 2 negative real, and therefore 2 imaginary, and for when I have 0 positive, 0 negative, and 4 imaginary solutions. So what the heck did I just do? One at a time, I just subtracted 2 from either the positive or the negative side, and whichever one I subtracted from, it goes to the imaginary side. So that these columns will always add up to 4. In other words, 2 plus 2 plus 0 is 4, 0 plus 2 plus 2 is 4, 0 plus 0 plus 4 is 4, and that's it. There's no other combinations. Actually, that's a lie. I missed 2 positive and 0 negative, and then that would still be 2 imaginary. And there, now I have all the combinations. And this would be my answer for the sign chart. I know it's confusing, but the best way to learn is just doing a few more examples, and that's what I intend to do right now. So for the first one, let's say I have y equals x squared minus 3x plus 5, and I want you to make a sign chart for all the potential possibilities. So I'm going to help us with this first one. How many sign changes do I have for my normal function? Well, it looks like I go from positive to negative and then back to positive. So that's 2 sign changes for the normal version, which means a maximum of 2 positive real solutions. Now to find the negative, I have to do p of negative x, or in this case, y of negative x. And when I do that, I'm going to get x squared plus 3x plus 5. Because remember, I'm switching the sign on all odd degrees, which is only the negative 3x in this case. So then I get this, and this has 0 sign changes, because it's all positive. And so that means I'm going to have 0 negative real solutions. And so with that information, I'm going to construct my sign chart with the positive real, negative real, and imaginary. Sometimes they want the total. You can put the total if you want. But I always like to start with the maximum for the positive and negative categories. In other words, I'm starting with 2, 0, 0, because we said 2 positive, 0 negative, and always start with 0 imaginary. Then the only thing I can do, I can only subtract 2 from the positive real. So that would mean 0 positive, 0 negative, and those 2 solutions I just lost went to the imaginary. And that's it for this sign chart. There's no other combinations I can have. And this is our final answer. So just remember that Descartes' rule of signs doesn't tell us what the solutions are. It just tells us how many and what kind they are. So is that useful? Who really knows? But clearly you're learning it, so it must be at least somewhat important. So here's the second one. F of x equals negative 4x to the fourth plus 6x cubed plus 3x squared minus x minus 2. So why don't you give this one a try on your own? If you don't understand, then, you can watch the answer. But I ask that you at least give it a try. So here's the answer. First, how many sign changes are there in the normal function? Looks like I go from negative to positive to positive to negative to negative. So in other words, 1 sign change there and then 1 sign change there. That means 2 sign changes for my normal f of x, which means 2 max positive real solutions. Then we have to find f of negative x. Remember, I keep all my even degrees the same, but I flip the sign on all my odd degrees. And we'll get negative 4x to the fourth minus 6x cubed plus 3x squared plus x minus 2. How many sign changes does this one have? So negative to positive, that's 1, to positive to negative. So that's 2 again. 2 sign changes for f of negative x. That means a maximum of 2 negative real solutions. And so now we'll make our sign chart. For this one we have 2 and 2 and 0 for my starting row. Then it doesn't matter which one I take away 2 from first. I'll choose the real. So 0, 2, and then the 2 that were lost go to the imaginary. Then I have to consider 2 positive, 0 negative, and then 2 imaginary. And then finally I could have 0 positive, 0 negative, and 4 imaginary. And that's all the combinations I can have. So that's it for this one. Now the one thing we have not seen yet, if we have an odd number of positive or negative solutions. We're going to see that happen in this example. So here's the third and final one we have today. Y equals 5x to the fifth plus 2x to the fourth minus 6x cubed plus 8x minus 3. So I just want to mention one quick thing for this one. I purposely left out an x squared. It jumps from x cubed to x. Does it matter if I have, let's just say, a 0x squared and I put it there in its place? The short answer is no, it doesn't make a difference. And as a matter of fact, you should absolutely not put the 0x squared there because it just makes it more confusing. And it would just be better if we left it like this. So go ahead, give this a try, make the sign chart, and when you're ready to see the answer, unpause the video. Okay, so first, how many sign changes do we have here? Looks like positive, negative, that's 1, and then back to positive, that's 2, and then positive to negative, that is 3 sign changes. Oh boy. So that means a max of 3 positive real solutions. Then for the negative x, all my odd degrees flip sign, and even degrees stay the same. And we will get this if you do it right. And how many sign changes does this have? Looks like I've got 1 there, stays positive, then goes to negative, and then stays negative. So only 2 sign changes for my negative real solutions. And so now we're ready for our sign chart. And I start out by writing the maximums: 3 positive real, 2 negative real, and 0 imaginary. And again, it doesn't matter which one I start subtracting from first. I'll choose positive real. Remember, you only remove multiples of 2. That means it's going from 3 to 1, and it will never go down to 0, and you can't have negative 1 solutions. So you're only going to see 3 and 1 for the positive real, and you're going to see 2 and 0 for the negative real. And then finishing this row. So we're going to have 1 positive real, 2 negative real, and 2 imaginary. Then I'll go back up to 3 and subtract 2 from the negative real, and that's going to be 2 imaginary. And then the only combination that's left is 1 positive real, 0 negative real, and therefore 4 imaginary. And that's all the combinations I can have there. And that's it for that problem. Now I know I said I was done, but some of you out there may be thinking, how crazy can this get? So we're going to look at the most complicated example you could ever see. Let's say 5 positive real, 4 negative real, and 0 imaginary to start off. So I guess first I would say 3 positive real, 4 negative real, and 2 imaginary. And then I'll go down to 1 positive real, 4 negative real, 4 imaginary. By the way, the order for the sign chart never matters, so I can go in any order I want when I take away the multiples of 2. Next, I'll go back up to 5 and take away 2 from the negative real. And now careful, there's only 2 imaginary because I put 5 back for the real. Now I need to zoom out so I can fit all these possible combinations in here. Next is 5 positive, 0 negative, and therefore 4 imaginary. Remember, as a quick check as I'm doing this, all of these rows should add up to 9 total solutions. This would be like an x to the 9th problem, which hopefully you'll never see in real life. And then we're not done yet because I've missed quite a few combinations actually. I can have 3 positive and 2 negative, and therefore 4 imaginary. I can also have 3 positive and 0 negative and 6 imaginary. And so let me think, did I miss any? Yes, I missed 2. I missed 1 positive, 2 negative, and that's going to be 6 imaginary. And then last but certainly not least, 1 positive, 0 real, and 8 imaginary. So honestly, a lot of this is just checking your work and double checking to make sure you got all the combinations. But once you have it right, this is it. So this is the final answer. Again, hopefully you never see an example like this in real life or imaginary life. That's some good math humor for you right there. But that's it for this video. If you have any questions, please post them in the comments. Thank you all for watching. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.